Hi, this is Karen O'Brien, and I want to show you a quick video on how to calculate Pier Scour with FLO-2D. So what we'll start with is the plugin manager. What we've done is added our repository to the QGIS plugins connection. So all you have to do is click Add, but I'll just double click it, and you can see that you can just name and enter this URL, and that will connect you to our repository. Once you're connected to the repository, you might want to start by uninstalling your current FLO-2D Gila and MapCrafter plugins. They'll be shown here. They probably won't say v2.0.0. So go ahead and uninstall those first by selecting them and clicking uninstall, and then go to all and limit the list by the word FLO-2D, as you can see. That'll get you to only our plugins. Select FLO-2D Gila and click reinstall, and select FLO-2D MapCrafter and click install. Sorry, you will see probably install, not reinstall. Okay, and then of course you close it and your two plugins should be ready to go. The MapCrafter plugin has some new features, so I've already pointed it to the output results, so we don't need to do that right now. But the new features are the project metadata, which gives you the grid size, number of elements, type of simulation, and computer runtime. This one took 2 minutes to run, and level of completeness. Then you can go to the hazard maps, which is where I added the CSU, or the HEC 18 CSU Pier Scour method. So you can just click create the map, and if you want to use the time-dependent data, you'll need a file called timdep.hdf5. Okay, I have that file, so I'll click that. I'm going to leave all of these values at their default level. This is your pier width in feet. The rest of these values we'll take a look at in a minute, and click Create Maps. Now I'm going to do that one more time, except this time I'm going to do max D and max V. And then I'll uncheck this and click Create the Maps. Now what that has done for us is given us two Pier Scour maps. One uses time-dependent value. That means the maximum of the depth and velocity is synchronized. And the other one uses the maximum depth or maximum velocity. So if you have ponded water, that might be skewed toward excessive scour because those two values are not synchronized, meaning that the maximum depth in a ponded condition happens at the end of the simulation, while the maximum velocity generally happens at the beginning of the simulation. So if those two are not synchronized, you might get skewed values. Or if your model is not stable at a certain point, then you might get skewed values. Whereas the time-dependent data should more accurately capture the depth times velocity, but with the time-dependent data, because it has an output interval, if that output interval is too wide, you might miss the actual peak of the event. So if your output interval is 1 hour, then your maximum depth or your maximum velocity might be happening in between the two intervals. So you might get better data if you use smaller intervals with this one. And this one might be okay so long as you understand that you have uniform overland flow and you don't have a lot of ponded conditions. I think that's it for now. Oh no, sorry, documentation. Let's go ahead and check out the documentation. So if you go to the home of the FLO-2D docs, you can get to MapCrafter and Pier Scour. So now this is just an outline of how we're applying the CSU method. And it gives you the equation, which is basically reliant on the width of the pier, the depth of the flow, and the Froude number, which is the data that you get from FLO-2D. The pier width is in feet or meters, and these additional coefficients are, with the exception of K4, are relatively simple. Because we're dealing with solar site models, we're probably dealing with circular cylinders, so we don't need to worry about the pier nose coefficient. That can be 1. And because we're dealing with cylinders, our angle of attack is not going to change, so this will also be 1. If you have a bed condition factor, we are not really dealing with large dunes on these sites because they're relatively flat, and the water does not flow over them for a long period of time. So we're just going to assume clear water scour with a coefficient of 1.1. And the bed armoring is probably the most complex factor. And also, according to the literature, it's maybe the most miscalculated factor. So I am not going to give you instructions on calculating this. You need to take your geotech team and you need to do an evaluation of K4 on your own. So I'm not even going to give you any ideas or instructions on how to do that. You'll get all of that information from HEC 18 guidance. So I didn't put it in here in my system. Per my, I have not seen a single report that defines how they are getting the K4. So I'm assuming they're either using one, which is probably conservative, meaning more scour, or they're using bed armoring. They're applying bed armoring in some kind of method, but they're not reporting on it in their reports. So that is all I have to say about the Pier Scour method. It's relatively straightforward and simple. It's just a simple post processor with a calculator. So I recommend that you use it with your own engineering judgment. All right. Hope that was helpful for you, and thank you for tuning into this video.